Hi, my name is Janet Raffner, and I am a research fellow at Aarhus Institute for Advanced Studies and the Center for Hybrid Intelligence at the Department of Management at Aarhus University. Today, I'll be introducing the co-creative design framework for hybrid intelligence. This is a structured model for understanding and designing human AI co-creative systems. This is a joint work between Nick Davis, Jacob Shearson, and myself. Co-creative AI is a subfield of computational creativity, an artificial intelligence that examines AI agents that collaborate with the user on a shared creative product. Hybrid intelligence is a computing paradigm that fosters progressively collaborative human AI interactions, aiming to establish a partnership between humans and AI rather than treating AI solely as a tool for human augmentation. And the research goal for our work is to develop a theoretically grounded framework for analyzing and designing human AI co-creative systems. Our work stands on the shoulders of many previous research articles, including those that you see here on the screen. The gap in the literature on current frameworks is primarily a lacking of a combination of cognitive mechanisms and interaction dynamics. So what we really aim to do with our framework is to have it be inclusive of both the cognitive mechanisms and the interaction dynamics involved in human AI co-creation. And so we put forth these three interaction dynamics based on synthesis from previous literature. And these principles are agency, interaction dynamics, and communication. And the co-creative design framework also includes cognitive principles. And from this, we build off of the 5 pillars of an action. And that includes autonomy and sense-making, embodiment, emergence, and experience. But the primary contribution of this paper is to dive into the interaction principles, agency, interaction dynamics, and communication. And you can see here that our framework is quite granular. So the idea with it is really that it can be used in practice, both for analyzing and for developing new systems. So within our framework, agency refers to how control over tasks and goals is distributed. Task specification can span from pre-planned to unstructured actions, while goal specification ranges from fixed objectives to emergent goals developed collaboratively in real time. Systems that support more co-creative interactions tend to allow both tasks and goals to evolve dynamically through that interaction. Now, when both the task and the goal are specified, the result is a scripted interaction. And you can see that in at the bottom left-hand corner. This is the most constrained of co-creation, where both processes and outcomes are predetermined. A common example would be a standard operating procedure in a controlled workflow with an AI system. In contrast, when the goal is clear but the task is unstructured, the interaction becomes an improvisational, goal-based collaboration, such as generating a response, a representational artwork where the end image is known, but the creative method is not. The most open-ended scenario occurs when both tasks and goals are unstructured, and this leads to improvisational open-ended collaboration, where tasks and goals emerge dynamically through shared interaction and mutual responsiveness. When the task is pre-planned and the goal is emergent, this is referred to as a scripted or exploratory interaction, where a particular method of interacting is defined prior to the interactions, but the end result is not well defined. And just so you can see here, when we go into more detail into the aspects of agency, we look at both the user agency and the AI agency. So in our paper, we also have these two figures, which gets into a little bit more detail as to what type of emergence and what type of improvisation you can see. So we look at both the human user and the AI user under the specified and unspecified goals, pre-planned tasks, and unstructured tasks. And this depicts that task and goal specification and the resulting improvisation or emergence. So we really hope that this framework can be used both when analyzing systems, but also when designing for one of these particular goals. So the interaction dynamics, this represents the structural how of co-creation, how actions are sequenced, distributed, and negotiated between humans and AI. And this dimension is particularly useful for comparative analysis because it captures visible patterns of task flow and division. So for example, you have interaction between collaborators and interaction on the shared creative product. And those are then broken down into action decomposition. So number of steps, ratios, order of steps, and then further into the categories for each of those. Communication is broken down into human to human and human to AI. Here's an example of that. And there are four categories of this: intention, action, interactions, and outcomes. So to demonstrate the value of our framework, we applied these leaf nodes to subcategories to a non-exhaustive list of exemplar systems, ranging from ChatGPT, GitHub Copilot, Midjourney, etc. As an example here, some systems such as Midjourney or DALL-E, they concentrate creative effort into single user inputs, followed by AI-driven outputs, reflecting asymmetry and temporality, compressed dynamics. Others like GitHub Copilot or Google Docs with Smart Compose, they exhibit more distributed and iterative patterns where contributions evolve through cycles of suggestions, refinement, and feedback. This variation then highlights how interaction dynamics are not only indicative of system functionality, but also deeply tied to users' perceived control, engagement, and creative ownership or authorship of the final product. By mapping these systems onto the subcategories, the co-creative design framework enables a comparative evaluation, which then can reveal which designs foreground shared agency and which ones constrain it through static or unbalanced turn structures. Then in the paper, we proceed to compare a traditional ChatGPT, which is what we know as the chatbot system, with the Canvas mode, which I show in a moment, and then also the DALL-E image generation. And here we give these examples to show the granularity and differences within interactions and how that affects the end user. So for example, we look at agency here. The user initiates interaction through prompts, open-ended user behavior with AI-generated structure. In the dynamics, interaction dynamics, there's single prompt, elicits comprehensive responses, limited turn taking, and the task is not decomposed. Communication, there's intent communicated via prompts and follow-up feedback with no localized edits. This is in contrast to the Canvas mode, where the user and AI co-construct outputs. The user guides the process through targeted edits and refinements. They can select which parts of the text they want to refine. The interaction is turn-based and editable interactions and fine-grained task decomposition, specifying which aspects should be worked on. For communication, there's direct manipulation of the AI-generated tasks, so the end user and the AI work on the product together. In DALL-E and ChatGPT, the user specifies a goal via a textual prompt. The AI generates imagery. Then a single image per prompt is created with no task decomposition, and here it lacks iteration. With respect to communication, it's one way, and further prompts generate new, potentially unrelated outputs. So for the key takeaways from this paper is that we integrate cognitive science and interaction design for modeling human AI co-creation. We present three new interaction principles: agency, interaction dynamics, and communication. And we continue building off these five cognitive principles: autonomy, sense-making, embodiment, emergence, and experience. And our exemplar work reveals subtle differences in interaction patterns among tools like ChatGPT, the Canvas mode, and DALL-E. Hybrid intelligence here emphasizes a collaborative human AI partnership beyond assistive roles. Future work in this area, we could work to refine the framework with broader interaction patterns evolving from Gen AI tools, validate the framework through user studies, comparing predictions with actual interaction data, and develop design heuristics and tools for practitioners building co-creative AI systems. And lastly, apply not just to evolving tools, but to diverse domain-specific fields. Thank you very much.